Saxon Algebra 1, Lesson 83. Students, I'm so excited to be here with you today. We're going to learn a style of word problem that is at the very heart of algebra. When people think about algebra, what is algebra? They often think of these kind of problems. They're called coin problems. You know a little bit about them already, but I will remind you. First of all, they're word problems that are built on a system of equations. Okay, so we'll be using all the skills we have to solve systems of equations in order to solve these coin problems. So you're already familiar with the mechanics of that. You know how to do substitution, and you know how to do elimination. We'll be using both of those strategies to solve coin problems. You also know how to solve a system of equations by graphing. We will not be using this to, we will not be using graphing to solve these systems of equations. So I'll just cross that one off because we don't need it. Okay, the trick to coin problems is to set up the variables properly. And the variables that we'll use look like this. And now you're going, oh, I kind of remember this. The number of nickels, the number of dimes, the number of quarters. Number of nickels, number of dimes, number of quarters. We've looked at these. We've seen these before in problems, haven't we? And I told you there would be words associated with them later. Well, later has come. The general rule of algebra is that we always need one equation for each variable. And what I mean by that is that if we have a problem with two variables, then we know we need two equations. That's what we'll be dealing with now. Just two at a time. Later, we'll get fancier and we'll be able to solve systems of equations with 3 variables and 3 equations. But for now, just 2. Our basic strategy to solving these problems will be to read the problem and look for things that are equal. That's kind of a general strategy for all word problems. We're looking for things that are equal because we use those to build them into equations. And you'll see what I mean when we get going here. That's what we look for though when we're reading all those mind-numbing words in a word problem is what's equal? What's equal in all of this? Or, as we have seen too, what is greater than or lesser than, because we can usually find a way to balance those out. Okay, example 83.1. Are you ready to begin? Let me read you the story. And then just listen to how it sounds. Don't try to make any sense of it yet. I always glance through a word problem first just to kind of get my bearings. Then I sort of sort through, okay, what's going on here? How can I make sense of this? Then I go back in and actually look for how I'm going to make my equation. Jack and Betty have 28 coins that are dimes and nickels. If the value of the coins is $1.95, how many coins of each type do they have? Have you ever had a big jar or even a piggy bank full of coins and taken them and dumped them out on the floor? That is such a fun thing to do. I used to be a waitress when I was in high school and college, and we had big pockets on the front of our tops that we had to wear. And I would come home at night and my pockets would be bulging with coins and bills. And I would just take them and dump them out on my living room floor at home. And that was always so satisfying. That's what I want you to imagine in the first part of these problems. We're just dumping coins out and Jack and Betty have 28 coins. They're not finding out how much they're worth. They're not paying attention to nickels versus quarters. That comes later. Right now they're just dumping them out, and what they're finding is that the number of nickels that they have plus the number of dimes that they have equals 28 coins. None of this is about what they're worth. This is just about the actual little round pieces of metal. If the value of the coins is $1.95, how many of each type do they have? Okay, now we're talking about what they're worth. So now we have to remember that a dime is worth 5 cents each. So I'm going to write 5 times the number of nickels. A dime is worth 10 cents each. So I'm going to multiply 10 by the number of dimes, and that equals $1.95. But there's a problem, there's a problem in my math here. These numbers are written in cents, these numbers are written in dollars. So what we do when we're setting up a coin problem, I could change these to decimals, but I don't want a bunch of decimals in my problem. Ew. I could take them out, but it's better to never even put them in. So what I do is I remember that 5 cents, 10 cents, I need to change this into cents. So $1.95 becomes 195 cents. I'm not putting the unit, the C with the line through it on these because that just makes it messy. But now all 3 of these numbers are written in cents. That's a very important part of the problem. And you can catch yourself because if you ever forget and just write this down, you'll see that decimal and go, dear Lord, I don't want that decimal in there, get it out. So that is one of the important things we remember when we're actually talking about the value of the coins that we have. Now, we've written our system of equations, and we're going to solve this in just a minute. You've had practice at doing that. What I want to show you here is that there's a pattern. First, we write an equation about the quantity that we have. This one is our quantity statement, right? It just talks about how many coins we have. The second statement is our value statement. It talks about the value of the coins that we have. We're going to use this quantity and value idea in other kinds of problems besides just these coin problems. My cat bit me last night. Isn't that terrible? I was petting him in a place he didn't like, and he is not one to bite. This is the first time he's ever bitten me, and he's 11 and a half years old. It was traumatizing. I looked at him and said, you are in a bad mood. Okay, so quantity and value statements. That also helps you just remember, what am I doing here? How am I setting this up? I like to write the Q and the V out here sometimes just to remind me quantity and value. Other times we'll move on. We're going to talk about buying mussels and cod at a fishmonger shop. We're going to talk about going to a dress shop that only has 2 different styles of dresses. So I don't know about that. First class and coach tickets on an airplane, all of them we're going to write quantity statements and value statements. So this pattern is really important that we notice. All right, now we are ready to do some solving on this. So let's use substitution. Now, what's cool with these problems is that John does not tell you whether you have to use substitution or elimination. You can do it however you want. So what I'm going to do is I'm going to change this one to be the number of nickels equals 28 minus the number of dimes. See, I'm just swimming that over. If this wasn't written here, I would have just done that right there, saved myself a little space. Now I'm going to plug this one into this one. What I do at this point is I just squiggle this out because that's not my working, that's not the version I want to look at anymore. I want to look at this one. Now I'm going to plug it in. 5 times 28 minus ND, sorry, I was already distributing too soon, plus 10D ND, sorry, equals 195. So I just plugged this into this number of nickels. This goes in there, and that's what I've got, right? This part I believe you're already familiar with because we've been solving problems like this. For my next step, I'm going to distribute, and I'll write that at the top of the next page. It is now 140 minus 5 and D, number of dimes, plus 10 times the number of dimes equals 195. For my next step, I'll put those two together, add like terms, and I'll swim this 140 across to the other side. Goodbye. Minus 5 and plus 10 gives me 5 times the number of dimes equals 55. To solve, I divide both sides by 5, and I get that the number of dimes equals 11. Now, I go back to my original equations, and I see that the number of nickels equals 28 minus the number of dimes. So 28 minus 11 equals 17, and here's a nice way to check. They have to equal 28, and that works. So here is my answer. This is a nice quick way to show that you tested to make sure that they fit what the equation said, which is that the total is 28. This is the right answer. Yay, you've done your first coin problem. Are you excited? I know I am. 83.2. Ming has $4.45 in quarters and dimes, okay? She has 8 more quarters than dimes. How many coins of each type does she have? Okay, so here's what I know. We're dealing with quarters and dimes, and I want to look at the quantity first, and it says she has 8 more quarters than dimes. Okay, that's an inequality. And I have to be careful because it is so easy to screw these up and write them the wrong way, write the equations the wrong way. She has 8 more quarters than dimes. That means the number of quarters that she has is greater than the number of dimes. In order to get these suckers to balance, I have to add 8 to the side that's smaller. She has 8 more quarters than dimes. We add the 8 to the little side, right? That's so easy to get wrong. We get it wrong all the time. She has $4.45. Okay, so I know that dimes are worth 10 cents, plus quarters are worth 25 cents, and that it equals $4.45, and I'm going to write that as 445 cents. Beautiful. Feel good about it? We set up, this is our value statement, here's our system, and we are ready to solve. Now, I was going to say, why don't we eliminate for a change? But this one's set up perfectly to substitute, right? Number of quarters. Why would we not, right? So, let's do that. We'll have 10 times the number of dimes plus 25 times the number of dimes plus 8. I'm pointing at the fact that there's my substitution. This is what I want to put in. There it is. And it equals 445. Beautiful, right? Distribution time. Eight times 25. Whenever I'm multiplying by 25, I think of having quarters. So I'm counting out 8 quarters. That I know is going to be $2, and that is 200. Sorry, I got distracted. Equals 445. And then I'm going to combine like terms at the same time I swim this 200 across. We can kind of combine steps now because we are pro at this. 35 times the number of dimes equals 245. And that, I do believe, is 7. Yes. I'll check that right up here. 35 times 7. And I'll tell you how I guessed 7 in just a minute. But first, let's check and make sure it's right. 35, 3, 21, 24. Yep, it works. Okay, so let me just do this. Number of dimes equals 7. Here's how I knew. Well, I didn't know, but my guess. I was looking at the 3 and the 24. 3 times 8 is 24, but then that wouldn't give me any room for all the 5s that I was going to have to multiply as well. So I backed off one and said, oh, 7 times 3 is 21. I compared that to the 24 and said, oh, that would give me 35. This 5 times the 7 would be that 35. So I was practicing dividing in my head, and I was simplifying the numbers because I can't think in that size numbers, but 3 into 24, yeah, I can do that. That's 8, right? But that doesn't give me any room for these. So that's how my brain was sorting that out. The number of quarters, now we need to find, and I see up here that the number of quarters equals the number of dimes plus 8. And that sounds like 15 to me. Those are the right answers. Yay. We have one more, my favorite number. And look, we're on the very back cover of the book. I'm getting ready to change. I hope you can see it okay. It's a little dark, but I'm just going to go ahead and work this problem here. 83.3. Orlando had a hoard of 22 nickels and dimes. See, like, you know, in your room you have a coffee can or something. Coffee cans are very old school. You don't have them anymore. I don't know, a peanut butter jar. You have some random container full of coins. He dumps them out on the floor and he realizes he's got 22 nickels and dimes. The value was $1.35. How many coins of each type did he have? Okay, so when he dumps them out on the floor, and he doesn't have any quarters or pennies in here, it's just nickels and dimes. So the number of nickels plus the number of dimes equals 28 pieces of metal lying on his floor. That's our quantity statement. It describes the number, but not the value of the coins. Now, whenever we want to talk about the value of the coins, that's when we start multiplying by what each coin is worth. Nickels are worth 5 cents each. Dimes are worth 10 cents each. And together they're worth $1.35, which I'm going to write. I'm going to show you the wrong way just to remind you. Not like that, like that, 135 cents. Now everything is written in cents. There's our system. Let's eliminate this time. Let's multiply this top row. Let's eliminate the ends. Okay, I'm looking down the rows, or the columns rather, to see what I can eliminate. I could multiply by -5, or I could multiply by -10. Let's keep it simple. Let's multiply all of this by -5. And that will give us -5 times the number of nickels, -5 times the number of dimes equals, this is 5 times 2 is 10. 5 times 8 is 16. No, it's not. That is a horrible lie. It's 40. Let me just do this multiplication right here because I'm trying to guess. I'm trying to do it in my head, and my head isn't cooperating. 0, 4. Oh, I see what I did wrong. I see what I did wrong. This number is not 28, it's 22. Okay, so when I multiply it, it's 110. I don't need that multiplication. 110. I know what the answer is, and so my brain is working backwards, trying to make sure that with each step I'm getting closer to the right answer. And I knew this should not be 140. And so that's why I was having such a hard time multiplying it, because my brain was screaming at me, no. And then I looked back and thought, that's not supposed to be 28, it's supposed to be 22. Now it's 110, now I'm happy. Now we're going to add these two together. The number of nickels cancel. 10 minus 5 gives me 5 times the number of dimes, and 135 minus 110 equals 25. The number of dimes equals 5, and we know that they have to add up to 22, so that tells me that the number of nickels equals 17, and I can draw a box around my answer. Then I can also do that little check to make sure that they equal 22, because that's what I said they should be equal to. This is the right answer. This is the way I want you to format your work and lay out your answer. Make sure that I can see the quantity and the value statement. Make sure that you can see it. I want you to clearly identify quantity and value statement, then go ahead and either rearrange this one or multiply, do whatever you need to do to solve. Substitution or elimination, you get to choose whichever you prefer. I recommend you mix it up. Don't use the same one all the time. If you like one better than the other, that's fine, but usually you like the one that you have more practice at. So don't ignore the other one. Give them both a chance. I love them both, and in the future, when we get up to having 3 statements of equality, you'll need to use both in order to solve the problem. So practice both, even if you have a favorite, right? Okay. Lesson 83 is complete, and so is my book. See you next time.